Good day, guys.
Good afternoon.
Good day, good day.
Okay, so today we are doing electronics N4, right, industrial. So this is still a module for electrical engineering N4. So we are still continuing with the same thing, the likes of circuits and stuff, but in this case now, we might be like a bit into depth with it, like we're going to get deep with it as well. So electrotechniques is just like theory part, then industrial electronics, that's when we are now, what they call it, applying all the theory part that we're learning from what electrotechniques into what industrial electronics. Okay. So the first thing that we're going to look at is alternating current theory. Just a moment. The first thing that we're going to look at today is alternating current theory, which is sometimes we refer to it as AC theory, right? So we are saying on the completion of this module, the student should be able to describe alternating current theory. I just want to ask guys, when you are charging your phone, or when you are charging your computer, or when you are doing anything that is that requires electricity, which kind of current do you use? Do you use alternating current, or use direct current? Feel free to talk, guys. We are here to learn, so everyone should be able to participate. So feel free to actually talk.
We're using direct current.
We are using direct current to charge our phones. So which type of current, guys, do we get? Like I'm assuming that most of us are getting electricity from ESCOM, right? It's just a few that are using, like for example, like inverters and generators. So those ones are using. Okay, most of us are using electricity from ESCOM. What kind of current is that electricity having? So we are saying we know that the electricity that we get, guys, within our household is one that we call alternating current altogether, which is the AC current. So we can see that whenever you are, like for example, whenever you're lighting a light, you just like a click, then you have what? Current. Or we have like light, right? So the one that we use, guys, to charge our phones and everything is AC current. Is the one that we are taking from the plugs. Are we together, guys? Then DC current, guys, is the one that we get from, let's say, for example, a battery. Then you have to use this. You see, like for example, when you're jumping your car and the other one doesn't have battery. So those ones, that current that is flowing through is what through those cables called DC current. Okay. So we are saying, okay, before I go further, do you understand the difference between alternating and this direct current? Mr. Tabi, so do you understand the difference now between alternating and direct current? Hello guys, can you hear me?
Hello?
Yeah, I'm saying, do you understand the difference between alternating and direct current?
Not really. Can you please explain it a little bit, please? Not really.
According to me, direct current is The current not moves directly, and alternating it is rotating. It's the one that rotates around our household. Then the direct one is the one we use for charging your laptops and phones. Hi guys, are we still there? Hello.
Hello, yes, sir.
Sure, Sillo.
Yeah. I don't know if it's network from my side or from your side, but like wow, it was just cutting a little bit. So I think you might have left me behind when you're still trying to explain the difference between the alternative and the direct current actually.
I think that attender is still off. I don't understand. Because I was asking, checking if he's still on. I think it's the network from his side.
Okay, probably he will be back actually.
Yeah. So did you go around this module, guys? Still.
No, I haven't really I haven't done that yet, so, to be honest, because of I'm so packed to be honest. But I'll just try actually. I'll just try. I think I need a weekend away from everything and do this model seriously. So on my own.
Even here it's the same. But I just watched a few videos on YouTube around the basics of industrial. So that's how I.
Maybe you can explain to us maybe in the meantime. Maybe we might understand you better.
I don't know as really much. I don't wanna mislead you guys. Yeah.
No, but I mean whatever you know, as little as it is, maybe it might make sense to our understanding, remember. So maybe you understand it simply, or you understand it maybe better. Maybe you can explain it simply, or maybe just round off this whole thing in just one sentence. Maybe we might understand actually.
Which part? The part we're starting with, the alternating current.
Yeah, maybe this part we're starting with, or maybe together with the other one that you think we might wanna know.
So as he was explaining, let me start there. Alternating current is an electric current which flows when electrons change periodically. Like in simple terms, we can say the current flows like rotational. Like there's positive and negative.
Okay, sorry guys, I don't know what was happening with my earphones here. I was trying to use them, but they're not connecting straight. Okay, so Travis, so you were saying you want me to redefine the difference between AC and DC current?
No, did you hear my answer?
No, I didn't hear that one. So yeah, let's hear it.
Oh, I was saying from my side, alternating current flows like rotationally, like it's the one we use here in the household, and then the DC, which is the direct current, we use it to charge our phone, which is one way. It's like a constant direct flow, like when you're charging a battery or your phone. So that's direct.
Oh, okay. Yeah, that's a very, very better explanation. Now, I want to ask something. So, we were saying that in the household, right, we are having AC current, but when we are charging the phones, we are using what? DC current, right? So, how do we convert now the current that we are having in the house from that AC to become DC? Because remember, I think from what you have said, is the AC is the one that we are using in the household, right? So, but now when you're charging the phone or when you are charging any battery, you're going to be using the DC. So how do we now convert from AC to DC?
I think from adapters, or is it resistors?
Sharp. So like whenever you plug in an adapter, the adapter is the one that is going to do all the work for us, right? It's going to convert all that thing for us. So we're saying alternating current is an electric current in which the flow of electronic charge like occurs in a reverse direction, like what we're saying, it will be reversing.
Yeah.
So they're saying this module demonstrates calculations involving what? AC current. Okay, so that's going to give us the first thing, which is what? Complex numbers. Okay. So here we're having what? Complex numbers like this, right? So when you're having complex numbers, we are having something like this. We are saying Z is equals to A plus what? JB, right? We are saying this is our complex number is Z is equals to A plus JB like this, right? So from this one, we are saying the Z is the complex number. Are we together? The Z is our what? Our complex number, right? Then the A, these two that we are having here, this one will be our what? Our real numbers, né?
What number, yeah?
Then this K that we are having here is the imaginary number, né? So sometimes you might find out that instead of using J, we use two numbers. We can use J as well letters, or we can use what? I. So all these ones, they have what? A certain meaning towards everything that you're going to be dealing with, right? So also in maths, we're going to be dealing with what? With these complex numbers. But now we are doing what? Industrial electronics. So we have to actually take them like step by step and understand how are we going to add different complex numbers. Okay. Were you seeing my pen screen, guys?
Yeah.
Oh, okay. Nice. So now we are having, for example, let's say we are having root of negative, what can I say? Root of negative 25. What would be your answer then? Root of negative 25.
So before we can continue, can I please ask, what is a complex number?
So when you talk about a complex number, a complex number is a number at which it has a perfect square, but we cannot get that perfect square from it because of a negative sign. For example, like I'm now saying negative 25. 25 is a perfect square, right? Because you know that if we say 5 squared, we're going to get 25. But now we have a negative within that word number. So we cannot now punch on a calculator say negative 25, root of negative 25. Because if you do that, we're going to get what? An error.
Okay.
All right. So let me just change the way I'm sharing this. Let me go to here. Okay. So for example, guys, we can have something like negative 25. Then here we are saying this is what? A root like this, right? So if we're having root of negative 25, what we're going to do with this one is that we're going to say root of negative 1 multiplied by what? Root of what? 25, right? Like this. So now we can see that we have separated the negatives from what? From the root. So we are having now a perfect square of what? Root of 25. So we know that root of 25 is basically what? 5, right? This side. Then, whenever we are dealing with complex numbers, guys, root of -1, right, is equivalent to what? This is what we are going to be now looking at from what? From, let me just go back to the PowerPoint presentation that I'm having here. You see, they are saying there is the real part A and the imaginary part B. Although B is the real number, it is referred to as the imaginary part because it is always linked to an imaginary J. The imaginary number has a value that cannot be written down accurately unless it is denoted as -1. So we are saying the imaginary number written as I or J is equal to what? Root of -1. So now that's when we are saying if you are having -1 like this, we're going to have our answer is what? J. Or sometimes you can write it as what? I. So at the end of the day, if you're having -25, your answer here is supposed to be what? 5J like this. Are we together there? Are we together?
Yes, we're together, sir.
Okay, so meaning that if we are to write this thing as an equation, it will be now Z is equivalent to what? 0 plus 5J, like this. So we are having what? These two here as the what? Real numbers, and we're having this one as what? Imaginary number. Or we can write this thing as 0 plus what? J 5. It's still the same thing. Is there anyone with a question on that one?
Can you please repeat?
Okay. So I should repeat from the -25 part.
Yes.
Okay. So we are saying we're having root of what? -25 like this, right? So
Yes.
this term that we are having here, we are saying it's carrying an imaginary number as well as a what? A real number. Are we together then? Because we know that this thing is the same as saying what? If you get confused on this one, let me know. It's the same as saying -1 squared, right? Multiplied by what? 25, sorry. I don't know why I wrote a squared there. We have something like this, right? Do we agree that this is the same thing?
Yes.
All right. So if this is the same thing now, what we're going to do next is that I'm going to say is equivalent to, this is going to be a root of what? -√1, right? Multiplied by root of 25. So we are still on the same page, isn't it? We just
No.
separated.
Yes.
Someone said no. Are we still on the same page here?
Yeah, I want to.
All right. So now, guys, whenever you see this thing is -√1 here, right? -√1, guys, automatically gives us what? J. Are we together there?
So it's an imaginary number.
It's an imaginary number. So we can use J, or sometimes we can use what? I. Are we together there? So it's always J, or sometimes you can use what? I. Okay, so we know that now on your calculator, if you punch root of 25, what are you going to get? You're going to get what? 5. So now when you combine the two now, you're going to have what? I or J5 or what? I5.
Right.
Like this. Are we together then? Is there anyone who is lost there before we move further? Okay, so the silence means that everyone is fine. Now, let's go back here. So we have find the answers to this one, right? So let us take this one and do it on our own, right? So I'm just going to do this. We are saying having something like this, right? So this one is equivalent to, we are saying it's 6, right? Plus or minus, right? Root of negative 16. All over what? 2. So, first of all, guys, we can separate this thing, right? To be 6 over 2, right? Plus or minus root of 16, which is negative over what? Over 2. Because there is one common denominator. So this thing that we're having here is the same as what we're having this side here. Okay. So now we can say 6 over 2, that's what we're going to get something like what? 3 plus or minus. So this is now root of 16, right? Negative 16. So if it's root of negative 16, this is going to be root of what? Negative 1 multiplied by root of what? 16, right? That's going to give us j what? 4. Are we together?
Okay.
So meaning that this is going to be plus or minus j 4 all over what? All over 2, like this. You can leave your answer like this, or you can what? Continue to solve it from there. Okay, is there anyone with a question on that one, guys? So here we are saying 4 into 4 is what? It's 2 into 2 is 1. Then here is what? Is 2. That's why you see that at the end of the day, they're having answer like 3 plus or minus 2j. Like this.
So that's the final answer.
Yeah, that is the final answer they're getting here.
So we can use rather I or they.
You can use I or you can use A.
Okay.
So they are saying the imaginary number j is equals to root of negative 1. All right, so we are saying the imaginary number j is equals to what? Root of negative 1, right? Are we together there?
Yes.
Then now we're saying, therefore, j squared is equals to what? Root of negative 1 squared, which is equals to negative 1. So we're saying, whenever you're having j squared, this one is going to be what? Negative 1. So some might be having a problem on how did we get to that point. Ne? So we are saying j squared is equals to what? Negative 1. Remember, guys, that the first we're having what? Root of 1, right? Is equals to what? To j. So we know that this is going to be 1 to the power of what? 1 over 2, right? Is equals to what? To j. Are we together here? So now we want to remove the what? We want to remove the half. For us to be able to remove the half, we have to multiply everything by what? By 2. Multiply everything by what? By 2. So here we have in a power 1. So this one cancels this one. You have what? Negative 1 is equivalent to what? J squared. That's how they are getting that j squared part. Is it complicated?
Not really, but yeah.
It needs a lot of practice, ne?
Yeah.
Okay. So let me go back down. So same applies, guys. You can hear I have a table here. J to the power 0 is equals to 1. J to the power 1 is equals to j. J to the power 2 negative j. So what you have to understand, guys, is that whenever the power that is having j is even, your answer to that is going to be negative. Are we together then? You can see that squared, here we're having j squared is what? Negative 1, right? J to the power 6, negative 1. J to the power of 10, negative what? 1. So these are what? Even. But now the question rises, what about 8, 6, and what? And 4. 4, 6, 8. Why are they not equal to negative 1? It's because of the squares, guys. Ne? It's just because of the what? Of the squares. So what you just have to know, I'll send you another also, what they call it, another table that will be having a bit of explanation on why is it like 4. For example, let us be together. Ne? Let me take this table here so that we know that we are done and dusted with that part. So we are saying we might have j squared, right, is equivalent to what? Negative 1. So if it's now j cubed, right? J cubed, what's going to happen here is that we're having what? J squared multiplying what? J. We are together, right?
Okay, what's the value of j? It's an imaginary number.
It's an imaginary number. So now we are saying if there's the power 3, this is j squared, and this is what? J to the power of what? 1. So if the bases are the same, what happens is that the exponent has to add. So that if we say 2 plus 1, we get what? This 3 that we're having here, right? But we know that, guys, j squared is equal to negative 1. So this is going to be negative 1 multiplied by what? By j. Hence we get what? Negative j. Like this. We're together, right? Then, no, you get it, don't worry. Then when now is j to the power 4, when it's j to the power 4 like this, right? We are saying this is what? J squared, right? Multiplied by what? J squared. So this is the same as saying what? Negative 1 multiplied by what? Negative 1. So if it's negative 1 multiplied by negative 1, we get what? 1. That's why it's what? It's positive. The square one is what is negative because that's the starting point. But now when we add 4, it becomes what? Negative. It becomes positive like this. So when it's 6 now, we add another what? J here. So that's how these things end up like to be what? but I think there was a mistake somewhere here on the 6 part. Here, because when there are 6, we are also going to multiply this 1 by what? By -1. Oh yeah, that's why it's giving us what? -1. There's no error here. It's correct. Okay. So what I want you guys to do, I don't like to just rush things, ne? I want you guys to actually understand. So can you prove for me, ne, from this one going down? Can you prove them? Why is J7 equals to -J? Why is J8? Yeah, sorry, J8 is equals to 1. May you just prove them in your books, ne? I'm giving you up to 2 to do that. I'm giving you 15 minutes to do that. Is it fine? Sabis, is it fine? Is 15 minutes okay, or there are a lot?
No, it's fine. Let's try it and see.
All right, sure. All right, guys. So did you manage to get the negative j's, 1, the positive j, and the negative 1? Did you manage to get that?
It's a bit difficult. So what I did, I said from J6, ne?
Okay.
I said J6 is equals to -1.
Okay.
And I said J is equals to 6 times -1.
J is like you are here at j. Okay, let me write it down. J to the power of 6.
Yes.
J to the power of 6 is equals to what? -1. Okay.
Continue to say J is equals to 6. Multiplied by my -1.
Yeah, so there's something wrong there, right? So let us do this thing together, because if we don't get the basics of this part, we're going to have a problem. So now we are saying here, right? J, we are saying j to the power of 6, right, is equivalent to, first of all, before you change anything, right, before you do anything, we have to change, because remember, the only thing that we know that we have, the value that we have, is j squared, right? But in this case, we do not have that j squared. Are we together? So if we do not have that j squared, what are we gonna do? What are we gonna do now? We have to change this power until we have what? J squared. So we're going to say is equals to j squared, right? The first one, multiplied by what? Another j squared, right? Multiplied by what? Another j squared.
Yes.
So now we know that if the denominators are the same, right? What happens to the powers is that the powers, they add to each other. So now we're going to say 2 plus 2, that's 4. 4 plus 4, that's what? 6. So we go back to having what? J to the power of 6. We are together there, right?
Okay.
So we haven't changed anything here. We are still having the same equation. But now we know that j squared is equals to -1, right?
Yes.
So meaning that here we're going to have what? -1 squared multiplied by what? -1. Sorry, remember j squared on its own is -1, so there's no need to write squared. Multiplied by what? -1 again. Multiplied by what? -1. So now, guys, on your calculator, we know that negative multiplying what? Negative gives us what? Positive, right? Then negative multiplying positive gives us what? Negative. Then positive multiplying positive supposed to give us what? It remains as positive, right? So now we are saying negative this one multiplied by negative this one. We are going to get what? +1. Are we together there?
Yes.
But we are still having another what? -1 that is outside of the bracket. So now if we say positive multiplied by this negative, we get what? A -1. That's where the negative comes from, which is this one. Which is the same as this one here.
So we go back to -1.
Yeah, because we had another what? Negative. So like what I was saying, guys, if ever you are having powers that are in odd values, like for example, how many powers are we having? We're having 3 powers here, right?
Yes.
So meaning that the powers are in odd. So if the powers are in odd, it automatically, your answer is what? -1. Right? Because the
Okay.
powers are in an odd form. But now if the powers are in even, we get a what? a positive 1.
Okay.
Yes.
So, please do the one for J7.
Okay, so when it's now J7, we're having J7, right? Which is equivalent to what? J squared multiplied by what? J squared multiplied by what? J squared multiplied by J to the power of 1. So if we say 2 plus 2, 4, 4 plus 2, 6, 6 plus 1, 7, right? So
Okay.
we know that up to here we did let me just take a red pen. We know that up to here, we know that the answer is what? Negative 1, right? Because it's the one that we got here. Now we are left with what? Another j, meaning that the answer will be equal to negative j, like this. Are we together?
We're getting there.
Okay. Now, do you want me to do with you guys J8 or you're fine now?
Can you please do it for us, Mr. please?
So J8. So now when we do J8, we are saying J to the power of 8, right, is the same as J squared, right, multiplied by J squared multiplied by J squared multiplied by J squared. So how many squares do we have here? 2 plus 2 plus 4. 4 plus 4, 6. 6 plus 6. 6 plus 2, sorry, 8. So now we know that J squared is equivalent to what? What is the value? What is the value of J squared? When they give you J squared, what would be the answer to that? It's negative 1, guys, isn't it? We said J squared here is equivalent to negative 1. So here it's going to be negative 1 multiplied by negative 1 multiplied by negative 1 multiplied by negative 1, like this. So this one gives you what? 1 as a positive number, right? And this one also gives you what? 1 as a positive number. Then that one, that's where you get what? A positive 1. Because we are saying positive multiplied by positive, we get what? A positive. From here, positive multiplied by positive, we get what? A positive. Are we okay? Okay, so we can continue, right? Okay, so we want to do the one that we call the Huygens diagram, right? So basically this diagram, what it does to you is it shows you the Cartesian planes and what they call it, the imaginary and the real plane. Okay, so let me take this thing out like this. And I'm going to post it here. So I'm having a plane here, guys. I'm having y and x-axis, right? So within these planes, the x-axis, we call it the real We call this axis the real axis. So we are saying the x-axis, guys, is called the what? X-axis. Sorry, it's not writing. Axis is called the what? The real axis, right? Then the y-axis on the other hand, the y-axis is called the what? The imaginary axis, like this. Sorry for this. Let me remove this. X is supposed to be as imaginary axis with an S like this. Okay, so all the values, guys, that you put on the x-axis are supposed to be real values, and all the values that you put on the y-axis are supposed to be the imaginary values. In other words, all the values that will be having a j, they are supposed to be on the y-axis, and all the values that doesn't have a j is just 1, 2, 3, 4, 5. Those ones are what? Our original numbers. We call them the real numbers. Are we together? So now, for example, you can see here they said 5 plus 3j. For us to have that, we're saying we're having a graph like this, right? Having a graph like this, then it comes also to be like this, right? So on this graph, we are saying this is going to be 1, 2, 3. Don't leave it at 3, guys. Put it to 4, right? Because we are saying this is the imaginary axis. So this is going to be 1j. Then this is going to be 2j. This is going to be 3j. This is going to be what? 4j, right? Then on the other x end, we're having this, and what, and this. So this is going to be now 1, 2, 3, 4, and what? And 5. So we are saying when it's 1, it's supposed to be 1j. Then when it's 2, it's going to be what? 2j. When it's 3, it's going to be what? 3j. And when it's 4, it becomes what? 4j. It goes like that. That's why we're having a what? A straight line going like this. And they label it as what? 5 plus 3j. So this diagram, guys, we call it the what? The Eigen diagram. And we're going to be using it for what? For complex numbers. Are we together then? So let's say, for example, they give us something like with the help of the graph, write down the geometrical effect of the following. So we have 1 and we have what? 3 minus j. Okay. So we want this number here. So we are having a number like written as 3j minus what? 2. Okay. 3j minus 2 like this, right? So now what you're going to do, guys, first of all is to come up with the what? With the graph, isn't it? So we have the x-axis and the y-axis here. We have the axis like this, axis. And also we have this axis, right? So now this is the y-axis. This is going to be our y-axis. And this is going to be the what? The x-axis, right? So now what's going to happen is that on the y-axis, that's the imaginary plane, so we're going to have 1, 2, and what? And 3. So it's going to be 1, 2, and what? And 3. But remember, these are to what? To j's, right? So it's going to be j, j. Then on the other side, you're going to have 1, 2, and what? And 3. Then you just draw a line here, like this. Then you say, this is the diagram for what? 3 minus 3j minus 2, like that. Is it difficult? Is it difficult, guys?
Is it done only like that, or it's just the first step?
This is the first step. So I want to take it like step by step. So I don't want you guys to have like stress. So I'm taking it step by step. We are supposed to end up having something like this. This is the complete diagram. That's
Okay.
all right. So I want you guys to draw for me 3 plus 2j, 3 plus or minus 2j. I want you guys to have a diagram for this. 3 plus or minus 2j. May you draw this diagram. Both of them, because remember, this is the same as was the first diagram is going to be number 1. It's going to be 3 plus 2j, and the other one, number 2, is going to be 3 minus 2j. So they're supposed to be different. I'm giving you guys 15 minutes. Let's do it. Okay, let's do it together, guys. I know time is not on our side. Some are working, so some they wanna go back to work as well. So we are saying here we draw one Cartesian plane, right? Let me erase this one first. We draw one Cartesian plane like this. Then so now we're going to have 1, 2, 3, 4, 5. Also this side 1, 2, 3, 4, and 5. Then we have also here 1, 2, 3, 4, 5. Then we have also here 1, 2, 3, 4, 5. So we know that this is going to be negative 1j, then negative 2j, negative 3j, negative 4j, negative 5j. Then here's what? 1j, 2j, 3j, 4j, as well as what? 5j. Then here we have 1, 2, 3, 4, 5, and here we have negative 1, negative 2, negative 3, negative 4, as well as negative what? 5. Like this, right? Now, the first one is saying 3 plus 2j. So here the positive sign, it means that all the values are in the positive direction. So we are having this one like this. Then this is what? 3 plus 2j because of the positive sign. Then the other one is going to be like this. Then this is going to be 3, sorry. So we're saying 3 is positive, 3 is positive, so it's going to come this side. Because 3 is positive. Yeah, 3 is positive here. Then the negative 2 is here, which is negative. The other one is 3 is positive, and also the 2 is what? Is positive. So this is going to be 3 minus 2j. But if this was minus, then it was gonna come this side. Yeah. But because it's a positive, it has to come what? This side. Yeah.
That's what I did, sorry.
That's what you did. Yeah, it's you have to check also the signs that this one is positive and this one is negative. Okay. Anyways, let's continue. Let's go to the we want to by the end of this lesson we want to be able to actually draw this diagram, right? Okay. So now we go to the modulus argument or polar form. So here guys, please make sure that you are having what is called a calculator. And when you talk about a calculator, guys, please do not buy Sharp, ne? Please do not buy Sharp calculator, that small one. We need Casio calculators because if you buy Sharp, it's going to be a very, very tough journey for you to do this N form. Okay, let's see. Now, the complex number can easily be converted into a polar form. For example, now you can see we have radius, we have theta, right? Okay, so find the polar coordinate of z is equals to plus j, right? So we're going to use this example here to actually explain everything. And please, if you don't understand, feel free to say, here, you are explaining, but you are alone. Okay. So they're saying, I forgot, I didn't take the question. Let me take the question. There we go. Find the polar coordinate of z is equals to 1 plus j, right? So what you're going to do with this one, guys, is this. It's very, very easy. Do not panic when you're having something like that. What you're going to do in that case, you're going to say, you have your diagram. First thing is to draw the diagram. Like this, right? And you can see that all the values are positive. So there's no need for you to write all of them. You can just say 1 here and also 1 here because they are positive. Then you have your what? Your angle going here. Then you say this is going to be your what? This is your diagram, and this is going to be your angle what? Angle theta. Okay. So this one, guys, we call it the radius, and this one is the what? Modulus. Ne? Okay. So for us now to find the angle theta, right? Auxiliary angle theta is equals to, because you can see this is angle theta. So we use those things of SOHCAHTOA or Church-Tual. So now we're having the adjacent and we're having the opposite. So we're going to say now tan theta is equivalent to what? Opposite of what? Adjacent, right? Meaning that theta is equals to tan inverse of opposite. So our opposite, guys, is 1 unit. From this point up to this point is only 1 unit over what? 1. So theta now becomes what? Tan 1 is what, guys? If you punch a calculator, tan 1 is what? Do we have calculators, guys? Or we are still to buy? Are we going to buy calculators, or we are? We have calculators. Tan 1 is what, guys, from your end? So we're going to get what? We're going to get 45 degrees, ne? So this is going to be 45 degrees, okay? Now, but we still need to get the r, which is the radius, right? So for us to get the radius, guys, we're having a small triangle like this. Having 1 here and also 1 here. So for us to get this one, I'm going to use Pythagoras theorem to say r is equals to what? Root of x squared plus what? Y squared, which is equals to root of 1 squared plus 1 squared. That's going to be root of what? 2. So you can leave it to be root of 2 is fine, or you can resolve it from there, but I always like to leave it as what is root of 2, right? So your answer now in polar form it will be now z to represent polar form is equals to root of 2 cis 45 degrees, or you can say Z is equivalent to root 2, then C is 45 degrees, like this. Are we okay there? Or we are confused? Are we okay, guys? We are confused here. Mr. Viso, are you fine?
I know I'm not fine.
Where are you lost?
They're on the what is it? You call it the theta.
Oh, so you are not understanding how tan became the inverse here.
Yes.
So whenever you're having anything like, let's say, for example, sine theta, right, is equivalent to 1. When the sine, this sine only jumps here, but without a theta, it becomes theta is equals to sine inverse of what? Of 1. Inverse means that if inverse is just like for example, we're saying theta of what? Sine is equals to what? 1 over what? So here we're having this sign here, then it cancels here. So when this theta comes here, you can see that it's on the denominator, so it's inverse of 1. That's why they write it as what? Sine inverse of what? Of 1. Okay, so I want you guys to try something like, for example, we have Z is equivalent to 2 plus 3J. May you try this one? Just 10 minutes only. Okay, guys, so let's do this together, because I know it's going to take us another time again here. Okay, so we are saying I have in Z is equivalent to 2 plus 3J, right? So the first thing, guys, that we said is to draw a small diagram, right? It doesn't matter about the value. So 2 is positive and 3 is positive. So the diagram is going to go like this. And this is going to be 1, 2, 3 on the imaginary part. And this is going to be 1, 2. So we go like this. And it goes like this. Okay, so we're saying this is 3J and this is 2, right? Okay. So now to get those other things, guys, we're saying we're having something like this. So we're having this one as 3, and we have this one as 2, and we're having this one as what? Theta, right? So here we are saying tan theta, right, is equals to opposite over adjacent, right? So meaning that our tan theta is equivalent to opposite is 2 over what? Over 3, right? So what you're going to do now, you're going to punch your calculator to get the value of what? Tan theta. Sorry, 2 over 3. 2 divided by 3, we get 0, something something. Meaning that your theta is equivalent to tan inverse of 2 over what? 2 over 3, like this, right? So meaning that your theta is equivalent to what? You're going to punch a calculator. Let me just correct this and punch a calculator here. So we're going to say 2 dividing 3, then second function tan. So we're going to get something like 33.69. So it's going to be 33.69 degrees, like this. Then your R will be equal to root of 2 squared plus 3 squared. So this is going to be your R is equal to 2 squared plus 3 squared. That's what? 9. So it's going to be root of 9. So at the end of the day, we're having root of 9 CIS 33.69 degrees, like this, which is the same as saying root of 9 C squared 33.69 degrees, like this. Okay, are we together there, guys? Did anyone manage to get that one? Monique, you're so quiet today. Are you winning?
Right. So this one is difficult. This module, I'm gonna have to really sit and go through it. If you can please send me this recording of the
Okay.
class, please.
Then, Chaviso? Mr. Chaviso, say.
Oh, yes, sir.
Are you winning?
Yeah, I tried it. I got
Okay.
I got 33 degrees.
Okay. Then, Mr. Selo.
Hello, sir.
Are you winning?
Yeah, I'm following behind. Yeah, I think I'll get there actually.
Okay. So I wanted to ask you as well that, like what we had studying, do you think it will be okay with you to just have the whole 3 hours like flat, or we can have, like, for example, we can start with 1 hour 30 minutes, then we take a break, then we come back again, we finish another 1 hour, 30 minutes. Which one is fine with you?
From my side, because like I'm attending from work, so I thought maybe like 3 hours straight to be better because of like I can just then when I'm done.
Okay, so that's one. Then the other one?
So I think in order for us to like really understand the work, I think we need to take a break in between because the 3 hours straight it's a bit hectic. But if others can't, then I guess 3 hours.
Yeah, but
But for
remember
me
that
personally, we need a break in between to at least go through the work, come back again, and then continue.
okay, then so when we take a break, guys, I say the break, let's say for example we take a break at 3. So we take a break at 3 and we will start again maybe at 6 p.m. So between that 3 to 6, you'll be doing some questions that when we come back at 6, we'll revise them. Then I think that way it will be better than me just explaining things, all of it at once. Some of them we might miss it.
Yes.
Okay, so Mr. Selo, even if we say we were going to attend at 6, you're not going to be able to attend.
Roughly by 6 my way, so I roughly get to my place around 7. Sorry.
Oh, you get around 7. And if we say we started at 7:30, some will be having load shedding at 8.
If you say 7:30, yes, I can manage them. But I'm not sure about others.
Are we 7:30, guys? Do we have load shedding at 7:30?
Even if I have load shedding, I can still connect.
Okay, then Mr. Taviso?
I have load shedding.
You have load shedding at 7:30. Okay, so how best can you do it? So is it fine for you to watch a video or you want us to continue to the 3 hours one? All right, so I guess let us just continue up to 3, guys. Then we'll connect again. So we said what time? 7:30 or 6? Which one is gonna win?
7:30, please.
Monique, you're fine with 7:30?
Yes, that's fine.
Okay, so guys, we're gonna use the same link. Ne? I won't send another link. You just use the same link that you have used now.
Okay. So can you
Yes.
please send this recording or the YouTube thing? I don't know how you're gonna do it, but can you please get this recording?
All right, it's not a problem. I'm gonna get you that. I'll send you as a YouTube video. Yeah, I'll upload it now, then send you as a YouTube video.
Okay, thank you.
All right.
Some like this thing, like I sending directly to her or to the group because of like all the other videos I couldn't get them.
Oh, like most of them, when I'm done, of course they are like the first one need to be 1 hour 30, the next one 1 hour 30. So I send them to the college, then they're supposed to send to you. But most of them have been sending them through the group, so they are supposed to be in the group chat.
On the group chat, it's only the maths recording. That's on YouTube now.
Okay, so it's okay, guys. Let me convert this one and send to you guys so that in the evening when we start, we'll be having somewhere to start. And also, I'm going to send some questions on the group chat. So may you please check them as well, those questions, because we're going to be checking them on that evening class at 7:30. All right, guys. So if there are no questions, guys, we can take a break for now. Okay, so we're still on the complex numbers, but a lot of us were having problems on how do we solve certain variables, right? So for example, we're dealing with example 1.4, whereby we're having find the polar coordinate of z is equals to 1 plus j. So the first thing that we said we have to do was to create a sketch. So we did create a sketch, and we had some other colored a diagram that we're now referring to. So whilst it's still there are certain things that you just have to remind each other, just a little bit, not a lot, but just simple things that you have to remind each other on that point. So we know that whenever we're having an equation that needs to be resolved, the first thing that you have to do, there are certain steps that you have to follow when you're dealing with complex numbers. Okay, so let me just show you these steps. Like, for example, let's say we're having we're going to have something like 3 plus, like 3 plus, we use 3, so let me change to 5 plus 7j. Okay, so we have this variable here, then we need to change these things to polar form. Okay, so we have to change this to polar form. Okay, for us now to be able to change this to polar form, there are certain things that you have to do, because you understand that this thing, when it's like this, we're having what we call a rectangular form. This is in a rectangular form. This one is called our rectangular form. Rectangular form. Okay, now for us to convert here, of course there are two methods. So the first method is by using a calculator, and most of us, unfortunately, we don't have the calculators at the moment, but as we get the calculators, there is a very, very simple way to actually get to convert any complex number that we're given from any variable that you're having towards to the polar form. But now, before break, we're having something like, let's say for example, when you're having this one, we're using the diagram method. So we're going to apply the diagram method. We're going to apply what we call the diagram method here. Okay, so when you're applying the diagram method, we're saying we have a diagram like this. We're having a diagram like this, then also like this. So we understand that from the diagram we're having the y-axis as well as the x-axis here as well. So this is our x-axis that we're having here. We're having our x-axis. So we're having our x-axis on this end, and also having the y-axis. So now we remembered that, or we can just like try to recap on the fact that on the x-axis, when we say we're having the variables that are on the axis are our imaginary variables. So here we're having the imaginary numbers only. So the imaginary numbers consist also of the likes of the imaginary numbers consist of complex numbers. So we know that on this diagram, guys, on the right side here, we're having positive, and on this side is negative along the x-axis. Then the y-axis, the upper part is positive, then the lower part is negative. Okay, So now the first thing that you have to do, you have to check now the variables. On this case, we're having 5 plus 7j. So now if it's 5 plus 7j, what we have to remember now is that 5 is positive and 7 is what is positive. So everything that we're having is supposed to be within this first quadrant. So what we're just going to do is we are going to draw a straight line like this. Then along that straight line, you're going to now label it. So we're just going to have like this, then also this. So we are saying this one, which is the imaginary, is going to be now our 7j, and this one, the real line or real axis, you're going to have the what? The 5. So now, when you are having these two variables that you have placed here, we have completed the what? The diagram. But now remember, we haven't changed this thing from what? From rectangular form. This is rectangular form to what? To polar form. So now how do we convert that? The first thing now, number one, is to what? Calculate. We have to calculate our angle theta. So now to calculate angle theta, we're going to say tan theta is equivalent to what? Opposite over adjacent, like this. So the reason we are saying that is that this one is called the opposite. Why is it called the opposite? It's called the opposite because it's on the opposite side of the what? Of the angle. And this is the adjacent because it's where the angle starts before it gets to the what? To the hypotenuse. So now we're going to say now our tan theta is equivalent to opposite. Now we are dealing with units. So whenever you're calculating this angle, there's no need for you to now use the j's because we are dealing with units. You're saying from this point here to this point, we're having 7 units. And also from this point going upwards, we're having what? 5 units. So we're saying opposite is going to be 5 over what? Over 7. But our main focus on this one is not to calculate tan theta, but we need to get the angle what? The angle theta. So now to get the angle theta, we're going to use the formula. Theta is equals to tan inverse of open bracket 5 over 7, like this. Meaning that now our theta, if you punch our calculators now, with the calculator, I still remember telling you guys or showing you guys how do we do that with the calculator. So we're going to say 5 dividing, let me just do this here, or times 0, so that I get the answer. 5 divided by 7, then I get this one, second function, tan. So I'm going to get something like 35.538. So I am having 35 point degrees. So this is the answer that I'm supposed to get at the first end. But now, even if I have the theta, I have this line. I have this line from here to here, and I also have this line from here to here. But now the problem is we do not have the length of this line here. So this line, we call it what? Our R, which is also called the modulus. So what you're going to do now is that we're going to say R is equals to the square root of what? Of x squared, or x unit squared plus what? Y units squared, which means that our R is equals to the root of x squared. We are saying that's 7 squared. That's going to be 7 squared plus our Y is what? 5 squared. So at the end of the day, we are having something like, if we are to punch our calculators, we know that it's going to be now 5 squared plus 7 squared is equals to 74. Then we need the root of that. So it's going to be now root of 74. 4. So this is going to be our answer. But now remember, the main focus of this was not to calculate only these two things, but was actually to change this a rectangular form to a polar form. So your answer now, your final answer will be equal to Z is equivalent to, sometimes you find that it is not an array at the top, so it's going to be Z is equivalent to root of 74 CIS 35.538 degrees, meaning that which is equivalent to root of 74. Then we have this thing as 35.538. Okay, so basically that's all about how to deal with these diagrams. Okay, so when you're at home or wherever you are trying these things, may you please just like try to do the following questions. I know it might be a bit tough, but don't be afraid to reach out to me if ever you have problems. So we are saying number 1, may you do Z is equals to 7 plus 8J. Number 2, I want you guys to do Z is equals to 3 plus 5J. So here I want you guys to change these from rectangular form to polar form. Okay. So now we can move back here and we actually check the other equations. For example, here you can see that, right, Z is equals to 2 plus 3J in CIS form. So CIS form simply means that we are converting that thing to a rectangular form. From rectangular form to polar form. So not that Z is equals to -2 and 3. Where are they getting these things of -3 and 3 is in the sense that I just want to try to enlarge this. How is going to be possible? Can't. So here on the question, you can see that Z is equal to -2 plus 3J. So if it's -2, -2 is this side. So I remember on the Cartesian plane, I said that positive is on the left along the x-axis. So now we're saying on the x-axis going to the left, you're going to have -2. Then on the y-axis, you're going to have what? 3. So now the first thing that we have to do here is to calculate the auxiliary angles, which is also called sometimes the modulus or the module. So we are having theta is equals to tan inverse of what? Of the unit. So it's going to be theta is equals to tan inverse of what? 3/2. So here there's no need for us to write -2 because we only consider the units. We don't consider the variables that you're having. So it's going to be now theta is equals to tan inverse of 3/2. Then we get this 56.309 degrees. Now, looking at the sketch, theta is equals to 180 degrees, then whatever, minus alpha, then we get that one. Okay, so they just wanted to get the other angle at the other end. But now to get the r is going to be now equivalent to -2 squared. You can even use 2 squared because we are dealing with units, we are not dealing with numbers. So it's going to be -2 squared plus what? 3 squared. Then you're gonna get root of 13, which is equals to 3.61. Working with complex numbers. Okay. So we have what we call the Morph theorem, which is use the polar form of complex numbers to find the product, quotient, and power of complex numbers. Okay. So we are having let Z1 is equals to R1 theta 1 and Z2 is equals to R2 theta 1. So sorry, theta 2. Whenever we multiply different what they call it, complex numbers, we're going to say Z1 multiplied by Z2 is equals to R1 multiplied by what? R2, which is equals to Z1 times Z2 is equivalent to R1 multiplied by R2, open bracket, theta plus theta. So here, what we are trying to say is this. Let me just try to write this thing down. We have something like we're saying Z1 is equals to R1 theta 1 and Z2 is equivalent to R2 theta 2, right? Something like this. So now to get Z1 Z1 multiplying Z2, we're going to have R1 multiplying R2, then open brackets or something like this, theta 1 plus theta 2. So these are basically formulas that we're going to be using whenever we are dealing with complex numbers, is basic theorems or basic formulas. So here we're having, whenever I have multiplication, we're going to use this, and whenever I have division, it's subtraction, then powers in complex is going to be R1 to the power of n, then you have n theta 1. Okay, so whenever you're practicing, I would